Hello students, today we will discuss mirror formula for concave mirror. So this is your concave mirror as I have shown in the diagram. This portion is the concave mirror. There is an object O here. This is the object O. Then from this object one ray is incident at point A, and after reflection it passes through the point I. Okay, and if we draw a particular line from the center of curvature of this mirror to the point of incidence, then this will behave like a normal. Okay, this will behave like a normal. So it will follow the law of reflection, that is, let me take this as I, and this is the angle of reflection. And as we know that angle of incidence is always equal to angle of reflection following the laws of reflection. Okay, following the laws of reflection. Now for the image generation we need minimum two reflected rays. So one ray is this one OA, then after reflection it passes through the point I, that is AI. Now another ray, let me take it as the incident from the object normally at point P, that is the pole of the mirror, and this is the pole of the mirror. Then it will again passes through the same, returns back through the same path C. Okay, because this is the normal path. Angle of incidence will be equal to 0, so angle of reflection will also be equal to 0. So these two rays meet at this particular point, that is point is I, and this is the image point of this object. Okay, this is the image of this object. All the distances of object and images are measured from the pole of the mirror. Okay, pole of the mirror. Object distance and image distance are measured from the pole. So now for mirror equation, let me take this as angle I, this is angle reflection, I and R, and they are equal following the laws of reflection. Then let me take this as angle alpha, then this is angle beta, and this is angle gamma. Okay. Now from the geometry of this particular ray diagram, if we look at the triangle, O A C. Okay, in triangle OAC, it will be alpha will be equal to alpha plus I equal to beta. Okay, because beta is the exterior angles to the triangle OAC. Okay, and we know that the exterior angles is equal to the sum of the internal opposite angles. Okay, here it is the exterior angle and alpha and I are the internal opposite angle. So this is the first equation that we have got. Now again from the triangle, again in triangle ACI, gamma is equal to beta plus R. This is the second equation. Now if we put gamma equal to value of beta as the alpha plus I, okay, or as alpha plus I, R is equal to again this, no, so we can put it as I, so we can put it R is equal to alpha plus 2I. Okay, if we put the value of I from these particular equations, we will get gamma equal to alpha plus 2 into beta minus alpha, 2 into beta minus alpha. So this will give us alpha plus 2 beta minus 2 alpha, 2 beta minus 2 alpha. So this is gamma. So gamma equal to, we will get alpha minus 2 alpha is your minus 2 alpha, and this 2 beta minus alpha. Okay, alpha minus 2 alpha. So we will get it as alpha plus gamma equal to 2 beta, and this is one particular equations that we will be in need of. So equation number 3. Okay, we have used here we have used I equal to R, and in this particular equation we have used, this is from equation number 1, from 1, okay, from 1 I have put the value of I as beta minus alpha, okay. So we have got this particular equation, alpha plus gamma equal to 2 beta, okay. Now if we take the Paraxial ray approximation, let me take this, okay. If we take the Paraxial ray approximation, taking Paraxial ray approximation, do you know what is the Paraxial ray approximation? Okay, because Paraxial ray means angles are so small, angles are small. Paraxial ray means those rays which are parallel to the principal axis and making a small angle, okay, that means angles are small. So from taking the Paraxial ray approximation, if we take the Paraxial ray approximation for alpha, this AP portion, AP will almost a straight line, almost a straight line. So we can consider AOP as the triangle. Now from this triangle AOP, we have tan of alpha equal to AP by OP, right? And this we can write as the alpha, because it is the small angle approximation, Paraxial ray. So we can take this as alpha. Okay. Let me take equation number 4. Then again in triangle ACP, okay, triangle ACP, we can write in triangle ACP, you can write tan beta equal to AP by CP, right? AP by CP, and it is approximately written as beta, because alpha, beta, gamma are very small angles, and we can write this approximation. Let me take this as equation number 5, and another equation we get tan gamma, okay, tan gamma from which triangle? It is from AIP, right? Tan gamma can be written as AP by IP, okay, IP, and it is approximately gamma. It is from triangle AIP, right? AIP, okay. So now let me take this as the equation number 6. Putting all these equations in equation number 3, using 4, 5, and 6. Using 4, 5, 6. In equation number 3, we get alpha means we can write it as, you know, AP by OP. AP by OP, then plus gamma means we have AP by IP, okay, from equation number 6, and is equal to 2 times of the beta, that is AP by CP, right? AP by CP. Now all IP are common, so in both the sides, so they will be got cancelled. If they will got cancelled, so let me see. If they will got cancelled, we will be left with 1 by OP plus 1 by IP equal to 2 by CP, right? Now, if we look at this particular diagram, you see OP is your object distance, that is U, okay, that is U. Then IP is your image distance, that is your V, and CP is your radius of curvature, that is R. So if we put these by the sign convention, using the sign convention, for sign convention what we will use, all the measurement that is in the direction of the incident ray, that will be taken as the positive direction, that is when plus sign, all the distances are measured from the pole only. If it is along the direction of the incident ray from the pole, then it will be taken as positive. And if the measurement is in the direction opposite to the direction of incident ray from the pole, then it will be taken as negative. You see, both all these measurements are measured from the poles, and incident ray directions is along this direction, rightward. Okay, then all these measurements as in the direction opposite to the incident ray and from the pole. So we have OP equal to minus U. Then we have IP equal to minus of V, and Cp equal to minus of R. Okay. Now if we put these values here, we will get, I think, 1 by minus of U, and minus of 1 by V is equal to 2 by minus of R. Okay, we have got this. So if we put these values here again, we will get uh, 1 by U plus 1 by V equal to 2 by R. Now we know that R equal to, F by 2, sorry, F equal to R by 2. Okay, if F is equal to R by 2, then if we put this, we will get 1 by U plus 1 by V equal to, if we put this equation, F equal to R by 2, that particular equation, R equal to twice F, so it will be 1 by F. Okay, so this is our particular mirror equation for the concave mirror. So I think all of you have understood these particular equations. 1 by U plus 1 by V equal to 1 by F, and in this particular equation we will put all the values with sign, with proper sign. Okay, for numerical questions. For numerical questions, we will put all the values of U, V, and F with proper sign. Okay, using the sign convention. So I think all of you understood. In the next video, I will bring the mirror formula by using the convex mirror. Thank you so much.